Okay, today we're going to talk about Modbus TCP between two Festo pieces of hardware. My YouTube site already has a YouTube channel or had a previous application guide, and I found out later that the audio was corrupt, so I had to do the darn thing over again. I didn't have the same hardware set up, so I'm using some different hardware. So if you still have the app guides from the Dropbox, links in the YouTube text, then good for you. There will be some new text and new Dropbox links in this video. So Festo has a PLC, a CECC-S. They also have a whole series of that. There's 3 of them. And then they've got a CPX-FB36, which is Ethernet IP or Modbus TCP capable. This is just a general overview. Let's see here. So this is a big overview. So I've got a FB36 with a 16 input, an 8 output, another 8 output, and then a couple small valves, and a CCC-S controller, a static switch, and that's about as simple as it gets. Okay, the next thing you want to do is download things from the internet. So the Festo website has all the information you're looking for. At the top of the Festo website, you go to support downloads area, type in FB36 for the Fieldbus node. You've got technical information, so this will be the user manual, software. You've got Festo Field Device Tool, Festo Maintenance Tool. That's an update. Festo Maintenance Tool. So this is so you download and install this one here, and then you'll do an update on that. And if you're using Ethernet IP, which we're not, then you would download the description file or an EDS file. Expert knowledge here is a good place to find application notes if anything exists. Go back to the main page here. If you then revert to the PLC, the CECC-S, same thing, CECC-S, enter button, technical documentation gives you the manual for it, software, firmware, field device tool, the CoDeSys package and installation files for the software that I'm using. So once you've got all the downloads and all the software and everything else you need, the first thing you want to do is wire things. So the FB36 has got 2 ports. It's got a linear switch inside of it, or it's just a switch. So you can either do a linear network, a ring network. But when it comes to Modbus, there's no such thing as a ring. You can do a linear and basically pass into the top port, come out of the bottom port, vice versa. Here's some typical wiring information, which will be included in the guide and the downloads at the Dropbox. If you want, you can change it from the IP60, whatever it is there, the 67, I think it is, it's rated for, and you can throw an IP20 thing in here and just hook up with RJ45 connectors. All right, so this picture right here, the 8DI.8DO, because this is a remake of a video, this is not exact. The first module is in fact a 16DI, and then 2 8DOs, like in the other pictures on the layout. But basically, you've got power coming in the bottom of the CPX manifold, power for the electronics, power for the valves are always segregated, and then you've got a common 0-volt DC for each one of those. When you're in Modbus setup, the LEDs mean different things than when you're in Ethernet IP. So this is a representation of the LED lights, not that I ever use them. Software is my thing. All right, so dip switches. So like I said, the FB36 from Festo is capable of a Modbus communication, Modbus TCP, or Ethernet IP. And the DIP switches here, the DIL switches they call them, Festo, decide that itself. So the green that I've highlighted here is what this particular module is set up for. The middle section is for, again, an IP address, but they're all set to off, which is factory settings, so that we can set them in the software. And the DIL switches are only observed on power up. So if you make changes, cycle power, otherwise you'll be pulling your hair out. There is also another switch over here, the DIL switch 2. It's important to understand that, hey, they do nothing in Modbus TCP mode. They do provide other diagnostics, but Modbus has its own diagnostics, which we'll discuss soon. So we can skip over this DIL switch here. You can do whatever you want with it, but basically you don't need to do anything. Modbus TCP general information. I'm not going to go through it. It's boring for most people that already know this. Well, here's something that's of importance. So the FB36, if you read the manuals, support the function codes that are listed here. So you've got 3, 6, 16, 23, 43. So the most common are 3 and 16, which are read and write individuals, and then 23 does the read and write all at once. So the 23 is supported by the FB36. And of course, you'll speed up your traffic, have less traffic if you use 23, but in my sample here, for sample purposes, I'm using 3 and 16, which is individual read, individual write. When you go through the Festo manuals for the Modbus TCP communications, you'll see that there are starting addresses where the inputs and outputs start, okay? And when you're using function code 3, the starting address for inputs is 45.392, and for the 16, it's 40,001. 23 is exactly the same thing, it's just a little laid out differently. And the most difficult part of determining the addressing and where the data resides for each of the modules in the CPX is in fact trying to determine where everything resides. So I've read the manuals and I've kind of done my own thing here, and everything's all the addressing is contiguous from left to right. And okay, so there, I'm gonna this guide here that I'm showing you right now. It's included with the Dropbox link in the video here. So go to the Dropbox link and download it. I don't want to get into too much detail here, but basically there's overhead for inputs and outputs with the FB36. There is a detailed explanation here on how that is laid out and what each thing means and what the bits and bytes are for. And then we extract the data sizes for each module type. So I have got a completed project here, and I'm just going to quickly show you the final product. I'll get into the details to arrive at this point, but basically you'll see here that in my input, so my read holding registers on my right, I've got some FB36 overhead data. So it's the same on every FB36. You've got diagnostics, system table, diagnostics data. That is shown right here, in this area right here on this page, if you want to get into details and look at the bits and bytes. The same thing applies to output area. You've got a diagnostic table right, system table right, and then the real data starts. So starting address 45.392. So the actual inputs themselves start there, but the physical I/O doesn't, because you have diagnostics information prior to that. Same thing with the 40,001. 40,001 is this one right here, and then 2. So in I think all cases, your first starting word will be at 45,395 for the read, and at 40,003 for the write. If you're, yeah, so let's go back to here. So when you look at the manuals, each module has a certain data space. Some occupy inputs and outputs, some occupy inputs only. So with the input modules, for example, this particular flavor of an application here has got a, just expand this here a little bit. So there's a 16-point input module to start off with. So you find this over here. You'll find that for the data size, or for the data inputs, you have 16 bits, so one word. And then the next word right after that is going to be the module diagnostics data. So if I look at the PLC program that I've designed here, 16-point inputs and then 16 diagnostics data. The next device or piece of hardware in the slot 2 is going to be the 8DO or 8 output module. If you go again through the code, you'll find that this module right here is the 8DA. So you have got outputs in the output area. Takes up a whole area. It's not using this part because it's word oriented. The outputs are also echoed, and then in the input area you get a diagnostics area. So going back to the code, you have one word of outputs, then you've got outputs echoed, and then the diagnostics data. The same thing applies for the next one, just because it's identical. And then you get into the last MPA-S. Do I have it in here? Yeah, MPA-1. So it's kind of the same idea. You've got outputs echoed, and diagnostics data. So in my code sample here, there's probably one other byte after this, but the Modbus doesn't really care. So basically, you've got the outputs, you've got the echo, and then theoretically, I should have one more word here that is the diagnostics data for the MPA-1S. Okay. All right. So scrolling through. So this is the best explanation I can do. Hopefully, it's made it a little clearer than the manual. Keep going here, and I've got some samples. I've got some freeware, the Modbus TCP client, talking to a variety of configurations. Shows you some ways of looking at, status information and diagnostics, and then error detection, status register sample. It talks about basic addressing rules, which is again part of the manual that Festo has. Diagnostics data, more samples of this addressing. And next thing we're going to just talk about the Festo maintenance tool software. So again, we have been at the website. We have downloaded the Festo maintenance tool software. We've installed it, and when you first start up, the first thing you'll be presented with is this right here. So let me just, for the sake of argument here, I'll close this and start it fresh. And so this is what's going to happen. You're going to get a blank screen. I'm assuming you're going to be connected to the physical FB36 or have the 36 part of the switch. Hit the next button. You select TCP/IP, hit a search, find some devices here, select it, hit the next button, finish, and you go online. You suck up all your information. So You don't have to do it. This is a diagnostics tool. There's also a diagnostics trace, which will give you the last couple days information, things like that. And yeah, so this is just a tool for understanding and getting advanced diagnostics from that particular thing there. So, yeah, okay. So I'm just gonna do a bold, and can I do a, well, whatever. So there's one more note here. So normally if you're doing an FB36 with Ethernet IP, the most important part of the Festo maintenance tool software is that you understand that there's a certain amount of input and output bytes, because that has to match the PLC. Otherwise you get a data mismatch. So with Modbus, the Festo maintenance tool software provides you with so many bytes, but it doesn't reflect what the Modbus mapping will be. So the Modbus mapping we've already talked about before is the correct understanding. As you see here, you know, if you compare, there's 2 bytes and 3. That's only, you know, 1 word input and 1.5 output. Whereas in here we've got, you know, theoretically we've got 11 input words and 10 output words. So it's important to know that you don't confuse yourself with the fact that, you know, there's byte pattern down here. The next thing just gives you some information on this awesome PLC, I think. The the version, or the CoDeSys version that I'm using is 3.5 Service Patch 7 Patch 2. It's very important to understand that because it's a little unique. The firmware that's in here has to be up to date to match the service pack. So it's got better features, less bugs, you know, typical same old software, hardware for manufacturers. All right, so when you create a project, let's go to the CoDeSys now. So I've already got this project done, but let's just talk about how I created it. So what should I do here? So I could just do a quick, okay, so I just opened up a new blank CoDeSys 3.5.7.2. You click on new project, you click the PLC type. I'm just going to call this a later. Hit OK. Yeah, sure. You come in here and you select your PLC type and the package. So this right here is what I'm using. 3.5.7.2.7 is the device version. Do I need a CAN open manager? No, I don't need CAN open because we're doing Modbus. I don't need IO link, master or device, and serial I don't need either. So I'm just going to stick with that. And what else did I do in here? I didn't do anything in there. So just going to hit OK. It creates a shell of a project. And if I follow my own guide here, so I've done this, I've added the device. The first thing we want to do is add a Ethernet. So come into here, add device. Bring this over here, field buses, miscellaneous, and depending on where you click here, oh, of course I'm in the wrong project here. So I'm in the delete project later, and add device, bring it over here, and so depending on where you click here, blanks or adds devices. So if I'm over here and I add different things, you'll see, you know, different things apply here. So click on add device, it adds the Ethernet port. And now you click on that device and we want to add a, what are we going to add? We're going to add a master, of course. Add device, and now we have a master added. And now we're going to add a slave, which will be the FB36. Add and close. So we've got that. So now we end up with this. At that point, I'm not going to go into that project. I just wanted to show you how to do that simple thing. So in here, you have an IP address here. Don't screw around with this. This is what it is. It just works perfectly fine. The Modbus master. This here should match your device. In this case, the FB36 works fine like this. There's nothing else that you need to do here. And then this right here, as you see, I renamed it. You just go to properties and then rename it to whatever you want. Under general, this right here is where you put in your IP address. It of course will need to match your IP address of your actual Modbus TCP device, which is what it is here. It shows right here. And response timeout, port 502 is a pretty common thing, and good. So I'm going to go back to the delete later project and just show you something right here. The important part of the offset. So you've got your slave, and now you have to build up what you want your slave to do. So you add a channel, come in here, you pick your function code. Typically you do a read first, then you do a write after the fact. The length, in this case it should be 11. I didn't do 11, I did 10 because of a mistake, but what's next? Okay, so the need here in the channel is to understand the offset, and we've already discussed the offset in the guide here. As we go through here, the offset is the starting address. So, if you zoom in here, the starting address, as we discussed already before, you've got 40,001 for the inputs, or the output, sorry, and you've got 45,392. So these numbers here are in hex, and converted to decimal, that's what they represent. The length is the length that you determine yourself. So you put a number in here, you say okay, and you've added this. You add another channel for the right, put in a length, add channel. So now you've got the channels there. When you do that, it opens up and adds these things right here. If I go back to my completed project, which you're going to have, I've done these properly. I've put the proper offset in, unlike I did before. You've got this right here. And what I've done here is, for the sake of this application guide or this video, I have labeled over here description on the right-hand side, the starting and ending addresses. And then I've given description right here. Just double click, start typing, hit the enter button when you're finished, and it'll be there. And this actually is a tag that you can use for your code. It's important to understand I didn't label the individuals, because if you label the individuals, at least on older versions, then it blows away this top one here. Okay, so what's next here? Let's zoom out. Oh, that's it. So that is it. So basically, I'm going to get to the delete me project and delete it. No need for that anymore. Nope. Other important things that I like to have set up in the project is PLC settings. You have a couple options here. I always say enable in the bus cycle task, update IO and stop. And that way, when you get down to here, use the parent bus cycle, so it'll be always updating this. So even if you don't have any code, it'll update these variables. And come back to here, communication settings. Come into here, double click on here, you see the PLC, you set active path, or you double click it, one of the two, hit save. You then need to, I'll do a clean all for the heck of it. Then I will do a rebuild. Oh yeah, so libraries. So 3S, who provides the software to Festo, has this, where is it here? Is it this one? Am I going blind? Oh, it's this one right here. So there's this library right here. And it seems a little bit out of date, this 3560. And I think because it's out of date, unlike most of the other things like the 357, it's a 3.5 Service Pack 6. That's why you get these warnings. And again, they're warnings. I've talked to Festo about this. They say that they're talking to 3S about it. I have no concern. The project works perfectly fine. I just ignore it and move on. So there's that. Close all editors. So we've done the rebuild. Now we'll generate the code. It would do this for you when you're doing the download. But anyway, now we log in. Log in. We're all good. We're stopped. So hit the F5 or hit this button right here. So hit the F5. Now we're up and running. And let's see here. So go to the I/O. Okay, so we've done a download. We've got some input. So bit 8. So input. This input's actually on. So let's look at the way that the outputs work. So the 8DO, so I have an echo for the output. So if I come in here and turn on the second bit, I just double click or click that and then Control F7 or debug Control F7, write values, because there's no code acting on this, so you can just do Control F7, you write to it, and then immediately you're going to have the mirror image of that coming back to you. Okay, if you look at the module itself, it's on. And that's all good. So I go to the next one here, turn on bit 6, for example. Now it's 64, and you'll see that the echo up here is coming back as well. Come down to a valve, turn that on. You notice that it's echoed back. And that's it. Well, I guess one more point worth mentioning is the fact that when you are, in fact, configuring these slaves, if I put in a length of 20, all you're going to do is take up a little more traffic by adding the extra data. It doesn't fault out when there's a data mismatch. So if you have a project where you're constantly changing things and you don't want to have, when you change the length of this offline, sometimes it wants to blow away your descriptions over here or blow this away. It depends on the version of software you have. That's why I just say unused placeholder so that I know that I can modify this project later for whatever I want. And that's it. I hope this helps you. Modbus TCP with an FB36 from Festo. Really simple. Nice little PLC. Good Fieldbus remote I/O node. It's not the best protocol. It's not deterministic by any means, but it's pretty decent, easy to set up. It's probably inexpensive. And that's it.